The idea behind Interactive Robogami is that we want to make robots easier to customize and easier to create for people who are not necessarily trained in engineering design. And so we've basically designed the system which allows people to do this design very intuitively. There are two main ideas behind it. One is easy fabrication, and one is being able to virtually verify that your robot will work once it's been fabricated. On the fabrication side, we've been using 3D printing and folding techniques in order to make the fabrication very easy. And on the functionality side, we've incorporated simulations in order to make sure that the robot can actually walk and can actually perform tasks. 3D printing has a lot of advantages. You can print very complex structures, they're very rigid, whereas in 2D fabrication, it's very fast, and you can create basically lightweight but still strong structures. We took the advantage of both of them, and we decided to 3D print 2D patterns. So this allowed us to get very rapid fabrication of stiff structures that are still lightweight.
So designing a robot is challenging because there are many aspects that must be designed. You have the 3D shape, the motion, the electronics, the control software. So how do you allow a casual user of any skill level to design all of these aspects at the same time to create a robot that will solve the user's task? Using our system, users can create a robot body by simply mixing and matching parts from an existing catalog. And in the same way, the user designs a motion for the robot by selecting from a list of suggestions and modifying the motion parameters. And all of the models designed in the system can be directly fabricated, and they are guaranteed to work in the real world. So what makes Interactive Robogami powerful is that it helps users in designing robots that will perform tasks well by guiding users in improving both the motion and the geometry of the robot designs. For instance, making the robots faster or more stable, or decreasing the fabrication costs to make them more affordable.
What we've put into the database are a lot of wheeled robots and some legged robots. You could combine any part you want in the database with any other part into as complex a structure as you want. Our system would help you make that design functional. What we envision for the future is that a user would be able to go into the system and basically define the behavior of this robot in terms of tasks. You can very quickly design a tool that you can print out and that will help you do these tasks very cheaply, very quickly, very easily. So the dream is that this tool would enable robots to become prevalent in our everyday lives. Since the system is geared toward making design easy, making fabrication easy, then it's basically lowering the barrier to having everybody design and create their own robots.
When you back it up and you drop it down low.